Namaskar. Today we will discuss local linear approximation of functions of two variables. Okay, in last class we have seen that the value of the function at this point can be approximated using the value of the tangent at this point. And what is this tangent? The tangent is at x naught. Okay, x naught f of x naught. And this is the value of the tangent at this point. That means this height. Okay, that is f of x naught plus f dash of x naught into delta x. Delta x is nothing, it is the difference between these 2 points. And also we have seen that the equation of this tangent, that is y of x or L of x, that is equal to f of x naught plus f dash of x naught into x minus x naught. Okay. Also we have seen that analogous to one variable calculus, the approximation of the function at x naught plus delta x comma y naught plus delta y is the approximation is f of x naught y naught plus fx of x naught y naught into delta x plus fi of x naught y naught into delta y. This fx stands for the partial derivative at x, partial derivative with respect to x at x naught y naught. This is partial derivative of y with partial derivative of f with respect to y at x naught y naught. Okay. Similar to this tangent equation, or this is the equation of this approximation. Similarly, what is the equation of this approximation? This is two variable calculus. So Lxy, instead of Lx, it is Lxy. Lxy is equal to f of x naught y naught plus fx of x naught y naught into delta x. What is delta x? Delta x is a difference between this new point and our original point x naught. Okay, here the point is x. This point is remains x naught. So the difference is x minus x naught plus into delta y. What is delta y? Is y minus y naught. So this is the similar surface corresponding to this approximation. Okay. In the one variable calculus, we know that this is nothing. This is the equation of this tangent. So what we expect? So we expect this is nothing. This is the equation of the tangent plane at this point. X naught y naught f of x naught y naught. Let us check. Okay. So this is our Lxy. And what is the meaning of Lxy? We can approximate our function using the values from Lxy. Here, that is we approximate fxy using Lxy. So we have to verify what is this Lxy. Is it a tangent plane or not? What is the equation of the tangent plane at this point? Okay, suppose this is our surface z is equal to fxy and this is our point x naught y naught. And what about this point? The coordinate of this point is actually x naught, y naught, z naught. Z naught is nothing, it is the value of the function at x naught, y naught. Okay, so that is our f of x naught, y naught. Anyway, let it be z naught. So we have to find this equation of the tangent plane in terms of the partial derivatives at this point, right? Then what is the general form of a plane passing through x naught, y naught, z naught? Yes, equation of the plane passing through a point x naught, y naught, z naught is nothing. A into x minus x naught plus b into y minus y naught plus c into z minus z naught equal to 0. Okay. So this implies z minus z naught equal to minus a by c x minus x naught minus b by c y minus y naught. Again, your a and b are two numbers. So we assume that this minus a by c is a number like a. Okay, we assume that minus a by c a. Similarly, minus b by c equal to capital B. So we can simply express this equation of plane is like this. Z minus z naught is equal to some a times x minus x naught plus b times y minus y naught. Now this a and b are unknowns. Okay, so depending on the plane, we have to solve a and b. Okay, to solve a and b, first of all we are going to consider the intersection of this tangent plane together with y equal to y naught. Okay, so what is the intersection of this plane with y equal to y naught? What is geometry? Geometrically, this is nothing. Suppose this is our plane y equal to y naught. It is parallel to xz plane, right? And what about the intersection? Yes, intersection is a line like this. This line is lying on this tangent plane, right? This straight line is lying on the tangent plane. So it is again a tangent. Tangent at this point. Clear? So what is the equation of this tangent? When y equal to y naught, this equation become, when y equal to y naught, this term becomes 0. So our equation is z minus z naught equal to a into x minus x naught. Geometrically, what is this? This is nothing. This is this straight line passing through x naught, y naught, z naught. And it is clear that this straight line is lying on this tangent plane. So it is tangent to this point. Okay. Okay. Then what is the slope of the straight line? Yes. Here the slope is a. Why? You can write this straight line as z is equal to ax plus z naught minus ax naught. A is a number, x naught is a x naught is a number, z naught is also a number. Clear? So now this is of the form some y is equal to mx plus c or z is equal to mx plus c. So this is our slope. So it is clear that the slope of this straight line is a. Clear? Then geometrically we know that this straight line is nothing. It is the tangent in the direction of x-axis. Clear? This tangent is in the direction of x-axis at x naught, y naught. So what is the slope of this straight line in terms of partial derivative? Yes, the slope of this tangent is nothing, fx at x naught, y naught. That is a geometrical interpretation of partial derivative at a point. This is nothing, this is the slope of the tangent in the direction of x-axis at x naught, y naught. Clear? Our a is same as this slope. So a is nothing, a is equal to fx at x naught, y naught. Clear? So now a is clear. That is the partial derivative at x at a partial derivative with respect to x at x naught, y naught. Similarly, you can find b. How? You simply consider intersection of this plane together with x equal to x naught. And what is this intersection? Okay, this intersection is nothing. X equal to x naught means it's a plane like this. So intersection is again a tangent. The intersection is again a tangent in the direction of y-axis. Okay, so we know that the slope of this straight line or this tangent line is nothing. It is b. So what about b? B is the slope of this tangent line. This tangent line is parallel to our y-axis or in the direction of y-axis. So this is nothing. This is our fi of x naught, y naught. That is a geometrical interpretation of partial derivative with respect to y. So now a and b are known. Okay. So by substituting this a and b in this equation, this gives the equation of the tangent plane. What is that? So this becomes z minus z naught equal to what is fx? What is a? A is fx of x naught, y naught into x minus x naught. So b is fi of x naught, y naught into y minus y naught. Okay. So this equation become z is equal to z naught. What is z naught? Z naught is nothing. That is the value of the function at x naught, y naught. That is our f of x naught, y naught. Okay. So z is equal to f of x naught, y naught plus like this. This is exactly what is our Lxy. Clear? This is they are same. So our Lxy is nothing. It is the equation of the tangent plane at the point x naught, y naught, z naught. Okay. So analogous to one variable calculus, our local linear approximation is nothing. It is the approximation from the tangent plane at this point x naught, y naught. Okay. That means suppose we choose a point xy somewhere near to this x naught, y naught. Then actual value of this function at x naught, y naught is on the surface. Okay. Suppose the surface is unknown. Then you can approximate this value using the value of the tangent plane at this point. That's the idea. Naturally, there is an error. Okay. We know that this error is less than distance between these 2 points. Okay. Anyway, this type of approximation, this approximation is called local linear approximation of the function fxy. Clear? This Lxy is called local linear approximation of fxy at x naught, y naught. And what is the advantage of this local linear approximation? This is a linear function. There is no term containing square or cube like that. Okay, it's a linear approximation. The linear functions are easy to handle for machines. Okay, for example, consider this problem. Let Lxy denote the local linear approximation to this function at the point 34. Okay, compare the error in the approximating f of 3.04, 3.98 by the corresponding approximation. What is the corresponding approximation? Approximation from the tangent plane, that is L of xy, L of 3.04, 3.98, with the distance between the points. We know that error should be less than distance between these points. Okay. Okay, so first we have to find the actual value, that means f of 3.04, 3.98, because our function is known, so simply substitute x by 3.04 and y by 3.98, that gives 5.00819. Okay, next we have to approximate this function value using our Lxy. So first we have to find Lxy. What is our Lxy? Lxy is given by this formula. And what about our x0 and y0? Yes, x0 is 3 and y0 is 4. Okay, so we have to find the partial derivatives with respect to x and y at 3, 4. Also, we have to find f of 3, 4. And what is fx at 3, 4? What is fx? Yes, fx is nothing, x by square root of x square plus y square. Similarly, fy is y by square root of x square plus y square. So now we can easily find fx, fy and f of 3, 4. And what is fx of 3, 4? You simply substitute 3 and 4. So that is 3 by 5. And similarly, you can find fy at 3, 4, that is 4 by 5. And what is f of 3, 4? Function is not. So this is square root of 3 square plus 4 square, that is 5. Okay, now everything is clear. So you can directly write our Lxy. What is Lxy? Lxy is equal to 5 plus 3 by 5 x minus 3 plus 4 by 5 y minus 4. Clear? Now the equation of tangent plane is ready. So now we are ready to approximate our f of 3.04 comma 3.98 using this tangent plane. So what is approximation? That is L of 3.04 comma 3.98. So this is the value of the tangent plane at this point x0 y0, right? So that is 5 plus 3 by 5, just replacing x by 3.04. So 0.04 and this is minus 0.02. And this is nothing, this is equal to 5.008. Okay, so this is our original value of the function at this point. This is the value of the tangent plane at that point. This is our approximation of this function. Okay, so what is the error? This is original value, this is approximated value. So error is nothing, it's difference. So this difference is 0.00019. Next, we have to compare this error with the distance between these 2 points. What is the distance between these 2 points? That is nothing, square root of delta x square plus delta y square. That means 0.04 square plus minus 0.02 square. That is equal to 0.045. So this is the distance between 2 points. This is the error. It is clear that this error is much smaller than this distance. Then how much? How much smaller? You simply consider the ratio. So we consider the ratio of error by distance. So that is less than 1 by 200. And what is the meaning? The meaning is the magnitude of the error is less than 200 of the distance between given 2 points. That means the error is less than 200 times than distance between points. Okay, that means this linear approximation is better. Okay, so next problem. Suppose that a function fxy is differentiable at the point 1, 1 with the partial derivative with respect to x at 1, 1 is 2 and f of 1, 1 is 3. Let Lxy denote the local linear approximation of f at 1, 1. Okay, Lxy denote the local linear approximation at 1, 1. If L of 1.1 comma 0.9 equal 3.15, find the value of fy of 1, 1. Okay. And we know that the local linear approximation of this function, that is Lxy, is equal to this one. And what is x0 and y0? Yes, here x0 is 1 and y0 is 1. Okay. So what is our Lxy? So our Lxy become f of 1 1 plus fx at 1 1 into x minus 1 plus fy 1 1 at and into y minus 1. It is given that L of 1.1 0.9 is equal to 3.15. So if you substitute x equal to, so you consider L of 1.1 comma 0.9, and what about its value? Its value is given, that is 3.15. And what about the right hand side? What is f of 1 1? F of 1 1 is 3. So this is 3 plus, so 3 plus 2 times 2 is fx11, fx at 1 1 is given, that is 2. What about x minus 1? X is 1.1, so 1.1 minus 1 plus fy 1 1 is unknown, that is not given, we have to find that value, into y minus 1. What is y? Y is 0.9, right? So 0.9 minus 1. Now everything is known except this one, so you can solve for this fy of 1 1. What is the value of fy of 1 1? Yes, by simplifying this expression, this is nothing, this is zero point 0.1. Similarly, this become minus zero point 0.1. Okay. Anyway, upon simplification, we have fy of 1 1 is 0.5. Okay, that's it. Thank you.